The next thing we need to talk about is boundedness, like the idea of a boundary. Boundary. Okay, I can almost spell. Okay, bounded below. There is a number, b, that is less than or equal to every number in the range of f, or every number, all the y values. This number, it's called b, is called the lower bound. So let's talk about bounded below. So here we are. Bounded below, if I have absolute value function, and let's say this value is -4, I say that this is bounded below, and the lower bound equals -4. Bounded above, very similar. We'll use capital B in this case. That is greater than or equal to. Oh, that's it, does not equal. I want to say equal to every number of the range in f. This number is called the upper bound. O-U-N-D. So if I have an upside down parabola, we see that, say that's my upper bound. Let's say it's 3. That 3 would be my upper bound. And if a function is bounded both above and below, I have a function that is called just overall bounded. You can see a function like this, and notice how we don't have arrowheads here. This is not a full, the domain is not all real numbers. But most of the time, a lot of times, we see unbounded with our function, that every number in the range is used. Again, we will be checking boundedness or estimating boundedness from its graph, just like we'll be doing with intervals. The next thing that we're going to talk about is extrema. Extrema deals with mins and max, extremes or maxima. So max and min we generally call extrema. So local or relative is a number that is greater than, okay, I'm having difficulty writing here. Let me just do this. So b is greater than or equal to all the range values or the y values on some interval. It's a sort of a closing area, not the entire range, but just some of them. An absolute maximum where b is, I can just write greater than or equal to all the range values. Therefore, b is called the absolute maximum, or just maximum. If we just say it's the maximum, that just means it's greater than everything. We can have multiple relative and local maximums, but there can be none or one absolute maximum. Relative minimum is very similar, but in this case we're looking at less than or equal to all range values. If it is less than, if that value is less than or equal to all range values for the entire f of x, we call it the absolute minimum, or just the minimum. And we can see, whoops, that was very quick. We can see for maximum we have two relative, and here's my absolute maximum. For minimum, we have a local min, but no absolute max. Local max here. Okay, we'll estimate local and absolute extrema from the function. There is an absolute maximum, but there is no absolute minimum. We can see that, and I'll highlight it in red. We see it because the graph continues down to negative infinity in both directions. There's a little bit of information here on the side about finding local extrema on your calculator. What I'd like to do is to have you go through that, follow these directions, find the local max, the local min, the absolute max, absolute min if they exist, and we'll go over them in class, next class. All right.